Estamos en vivo. Hello everyone, we are live right now. We are here with Richard.
Yeah.
¿Qué tal?
Yeah, buenas noches.
Hello.
Ok, ahí esperemos mientras que van llegando las personas. We are live right now. We are here with Richard. ¿Qué tal? Las personas ya nos están siguiendo. En minutos, ¿no? 1 or 2 minutes before we start. Ahí están siguiendo, hay varios. Gracias muchachos por seguirnos. Jesús Suárez, Geboni. Todo tuyo la escena. Yo creo que empecemos y ya vamos viendo.
Perfecto. Bueno, comunidad, buenas noches. El día de hoy continuamos con los meetups que hemos iniciado hace un par de meses. Y el día de hoy tenemos un invitado internacional. Tenemos a nuestro amigo Richard Fan. Lo voy a presentar a Richard. Richard actualmente trabaja para la empresa GrowOps como Cloud Engineer, ¿no? Y Richard actualmente gestiona la infraestructura de tecnología de Cloud para una de las instituciones financieras más grandes de Singapur. Y también les comento que Richard posee la certificación AWS Architect Professional. Entonces, aprovechemos al máximo el día de hoy en hacerle todas las consultas. Pueden aprovechar en escribir cualquier duda que tengan en la caja de consultas y al final nosotros la vamos a hacer llegar. Richard, the audience is all yours.
Yeah, thank you. So, hello everybody, and thanks for joining. And today I'm going to talk about the API gateway. The topic is don't use Lambda to move data. API gateway can help. But obviously I'm saying Lambda is not good, but we can do better with using some powerful features from API gateway. And so first, who am I? I'm a cloud engineer from GrowOps, and my team is currently managing the cloud infrastructure for a financial institution in Singapore. And I was also a software engineer, and I also built some data processing applications and backend system for B2C web and mobile apps. And I also AWS Deep Racer finalist in both last year and this year. So first, before diving into API Gateway, I want to talk about why I come up with today's topic. So if I ask you, how does your first serverless app look like? I think most of the people will answer this. We use API Gateway to route traffic and then pass it to Lambda, and we will write the code to handle the business logic in Lambda. And we use DynamoDB to store data. And why many people do the serverless app like this? The first reason is because the Hello World sample, the tutorial tell us to do that. So we just follow this pattern. And the second reason I can think of is because it looks like what we did in classic monolithic application. For example, back in my earlier career, I used Nginx to do the routing traffic and use G-Unicorn to pass those traffic to Django, which is a Python web application framework in Django. And I write all I want to do, I just write the code in Django. And then behind Django, I will use MySQL or PostgreSQL as a database. Last month, I saw this tweet. A person complaining a so-called simple function as a service, or what we call serverless. And I think that's true, because many people have an illusion that serverless is simple. But if you have read the AWS white papers, you can see many architecture is very complex, just like this picture shows. But why is it the case? Why we think serverless is simple, but turns out the architecture have so many errors, just like what we saw here? To answer this question, let's look back what we did in classic application architecture. Does this diagram show the whole picture? I will say no. This diagram is oversimplified because we put everything in the application layer. So when we host a server, we can put everything into our code because the server is already there. We can do whatever we want in our code. We can even do many crazy things, just like many people do an infinite loop to do the cron job, or many other crazy things that people can think of. They can do it because the server is owned by ourselves. But when we turn to serverless, of course, we don't have to concern about the resource provisioning because it is taken care by AWS. But at the same time, it also means that we lose control over the underlying infrastructure. So we should really think of the capabilities of each component, because each component is not owned by us. They have their own capabilities, they have their own limit. What we can do, what they cannot do, or what we shouldn't do on those components, we have to think about it. And how we can better connect each component. That's why serverless and microservices always come together. That is, we need to think about each component, what they have to do, and they need to do what they're supposed to do, but not extra, not less. And this is microservices. So back to our topic. Why do we want to avoid Lambda? First is the cost. So you can see this diagram. You can see a route traffic to API Gateway, then to Lambda, then to DynamoDB. But what if I tell you API Gateway have the capabilities to directly talk to DynamoDB? Then if we know that, then we don't need to use Lambda. Just don't use it, because pay what you need to use is one of the advantage of serverless. And second is the concurrency limit. Currently, AWS Lambda allow up to 1,000 concurrent run in each region. So if we put everything, even the simple thing into Lambda, then we may easily drain out the limit. So we want to, for some simple requests, then we just want to bypass Lambda so that we can reserve those 1,000 concurrent limit to those complex things that really needs Lambda. And number 3 is avoid unnecessary layer. And if you have ever built a serverless application, you probably know that handling error or even debugging is very difficult. Error can occur anywhere. You never know who is actually throwing the error. So it's especially true when we think about the retry logic. If every layer has its own retry, then it's very easily to make the system fail. Think about it. If DynamoDB throw an error, then Lambda going to retry. And after the retry, Lambda throw the error to API Gateway, and API Gateway retry again. Then it would be a very terrible retry loop. So we want to avoid some unnecessary layer to make things easier. Okay, today we are going to talk about API Gateway. So what you may already know is, I think every people know that it can route traffic to Lambda, which many people do that. And some people may know that API Gateway can help you to do throttling. So you can throttle the API Gateway so it won't overwhelm the downstream service. What you may not know is, I think many people don't know API Gateway can help you to validate user input. It can also transform the request and response format. And also it can integrate with other AWS services. So with those capabilities, we can do many things without writing any Lambda function. So let's go to the exciting part, the demo time. So today I'm going to walk through how we can use API Gateway to do a read operation on DynamoDB. So first of all, for today's demo, I have already created a DynamoDB table here. You can see it's a very simple table. It's just I just use ID as a primary key. So I think nothing special to this table. So before we actually create the API Gateway, we need to create the IAM role to so that we can grant the API Gateway permission to access the DynamoDB. So how we do that? We go to IAM console, and we click. We are in the IAM console, and we click roles, and then we create role. So here we are going to grant access for API Gateway. So we choose API Gateway, and we just click next. Then I will give it a name. Okay, a random name. So after creating the role, you can see that by default it has already attached a policy here is for API Gateway to push logs to CloudWatch logs, but it's not enough because the goal is to grant it permission to talk to DynamoDB. So I will add an inline policy here. So JSON. I've already prepared the IAM policy. So I will paste here. You can see I grant the DynamoDB read-write permission to this table, which I've already shown to you. So review policy, and give it a name. Okay. So we have created a role so that we can later attach this role to API Gateway, so that our API endpoint have the permission to talk to DynamoDB. So the next step is we go to API Gateway, and we will create a new one. And you will notice that API Gateway have many API types. So you can see that for HTTP API is the most cheap one and the most easy one. But you can see it can only work with a Lambda or even another HTTP backend. But today, with AWS services, so we are going to REST API. You can see that it can run AWS services. So we choose REST API today. We click build. And before, yeah, so we need to give it a name. So we stick to default one. We use REST, and we will start from scratch. So okay, give it a name, and okay. Then before we actually create the method, we will go to models. You can see in the left menu, and we can see models. So we will create a model. What model is that model is using JSON to do validation. So what we do is we need to define the schema. So that the schema is what we expect the user to input in their request. So we will use JSON schema to do validation against every user input. So if you take a look at JSON-schema.org, you can see they have a dot to tell you what we can do in terms of validation, like properties. If we define our schema in properties, you can see we expect a string in street name, and also we expect a number in the number field. And it also gives you the example like why this input, if the user pass this input to us, why it is failed is because it provides the wrong type in number. You can see it provides a string rather than we require a number. So today I'm going to create a simple schema that you can see. What I did is for the post request, I will require user to pass me the ID and name. And for name, I will expect string. For ID, I will expect integer. So this model, I will later use it to validate the post request from user. So I will name it a post request model, just a random name. And content type, I will use application JSON. So I will expect user pass the JSON to me in the, so I will click create model. So after creating the model, I will go back to resources and we will create a post method. We click action and create method, and in the drop down menu, we choose post. Okay, for this post endpoint, I will use it for user to create a new record in DynamoDB. So a user will use post request to like pass the data here, and we will create a record in DynamoDB for them. So here you can see this page is the integration request page, which will automatically show up after you create a method. So in integration type, I will choose AWS service. So you can see many options. For AWS region, because the table is in US East 1, so I choose US East 1. And for AWS service, definitely we are going to use DynamoDB. And then subdomain, I will leave it blank because DynamoDB don't have any subdomain. So for HTTP method and action, we need to go to AWS documentation. So if you don't know, API console or even command line, actually all our interaction with AWS is going through the AWS API. So AWS API for different AWS services, they have many different actions. So if you want to look for what provided, you can go to docs.aws.amazon.com and select the relevant service. So at this time, we're going to use DynamoDB, and we will use, you can see there are many actions supported by DynamoDB. Actually, if you are using console, the console is doing the API call for you. It's the same. So today, I'm going to use put item. You can see put item. What it does is create a new item. So for action name, I will use put item. So how about the HTTP method? So we can scroll down to example, and you can see some sample requests. You can see for put item, we are going to use post. So back to the console. So HTTP method, we are using post. an action is put item. For execution role, we will use the role we have created. So we copy the ARN and paste it, and that's it. We save. Oops. So we have just configured the integration request part. So one step back, we need to configure the method request, which is how we handle the user input. So we click here, and you can see there's a request validator. So in this post method, we are going to validate the user request by their request body. So we click the pencil icon and choose, we will validate the body. So choose validate body, and OK. So how we are going to validate the body, and you can see here, we have the request body. So you can see model name, which we are going to attach the model which we have defined before. So we click add model, and for content type, we are sticking to application JSON, and for model name, we will choose the model we have created. And OK. So now every user using this post method, API Gateway will validate the request body against the model we have defined. So let's try it out. And we go back and we can click the test button. At the test button, we can do debugging without really deploying the API Gateway. It's really useful. So we click test. So here we put some request body here. Let's say as a user, I input an empty JSON object, then test it. So you can see it's a 400 error. But if you see look at the message, it's really useless because it just say invalid request body. But valid request body should how should it look like? It doesn't give it. So in order to provide a more meaningful error message, we can go to and in gateway response page, we can see different error type. We can customize the error message for each error. So in this time, we are going to customize the bad request body. So if you look at it, application JSON, you can see this is the template that we have seen in the error message. It is just showing the error message. So it's not useful. So we're going to edit it. So here, we are going to change the error message to this. So we are going to change it to provide the validation error rather than just the error message. So this context variable is very useful because API Gateway will provide many information in this context variable. So what is inside this context variable, we can always check with API Gateway documentation, but today I'm not going to go through it. But to let you know, validation error string is message that change the response status code for app. So we click save. So we go back to the post method and see how it looks like now. So we click to post and test. So again, I'm inputting the empty JSON object. So here we can see more meaningful error message is that object has missing required properties, ID and name, because in the model I have defined that ID and name is required. You cannot miss these two properties. So now I will input a valid request which have a name and ID. So we try it out. So you can see. So these requests pass the validation. But if you look at the logs here, you can see this is our input. Pass input directly to DynamoDB. DB is responding to 400 error. What if you look at this request payload and compare it with the DynamoDB Don't, you can see it's different, the format. DynamoDB is expecting this format of request, but not this. So how can we transform this format into this format so that DynamoDB will understand? So to do that, we are going back to integration request here. So if you scroll down, you can see there's a mapping template here. So here I will choose never, which I will tell you why. And here I will add a mapping template. So application JSON, and click tick. So let me tell you what is going on. Mapping template is that API gateway will look for the content type for each request. If it match the content type, which like I said, I will pass as a customer, I will pass JSON to this endpoint. So API gateway will look for this list and look for JSON, and it will use this template to transform the request. Why I choose never pass through? Because when I choose never, the endpoint will only accept JSON. If it passes some XML here, the API gateway will reject this request, so that I can ensure that every request will walk through this template, expose the DynamoDB endpoint to the public without doing the transformation. Then it will be very dangerous, because anybody can do anything to the DynamoDB by inputting their own request payload. So back to the template. So I'm going to use this template. So this template is using Apache VTL language, which is a template language you can use to construct your own request. So you can see here, I'm going to construct the request payload that Amazon DynamoDB is expecting. And here you can see some syntax. Like for ID, I'm going to extract the ID from user input. Then I'm going to extract this set action, which you can go to Apache VTL documentation to see how VTL syntax looks like. But today I'm not going to talk about this. So okay, for the same payload, I'm going again. So if you see the log, you can see the endpoint request body after transformation. So API gateway actually use form this input into the format that DynamoDB understands. So you can see the API gateway use my template to extract the ID and the name from my input and place it in the place I have defined. So you can see API gateway sent this request to DynamoDB and actually receiving a 200 OK response. So if we go back to DynamoDB and take refresh, you can see we have already created an API endpoint that we can pass the record here, and we can actually create a record without writing any Lambda function. So besides post method, I'm going to create another method, which is get, because the customer will definitely want to see the record from DynamoDB. So I'm going to create a get method. So again, I'm going to choose AWS service, and region again is US East 1. and DynamoDB for AWS services. So here, I'm not going to use put item this time because I'm going to get the item. So back to the DynamoDB documentation, and now I'm going to use a query. You can see query operation is to find the items based on primary key. So my get method, which I'm going to create in API Gateway, is that I will take the primary key from user input and return the items to the user. So I'm going to use query. And if you look at examples, you can see the sample request, which is query is using post. So we have these two information. Then HTTP method, I will choose post, and action is query. And again, execution role, I'm going to use the role ARN. Okay. So save. So we are going to accept customer passing the ID in the query string. So we need to define it in a method request here. So here you can see a request validator, and this time I'm not going to validate the body because get will not use this, but rather get method will use query string. So I'm going to validate query string instead. So we click OK. Then here you can see URL query string parameters. So here we can define which query string we are going to expect from the customer's input. So here I'm going to add query string. If the user provide the ID to me, then I cannot do the query. So I will mark it as required. Okay. So again, in the integration request, we are going to construct a request that DynamoDB is expecting. So we are going to integration request. Again, scroll to the bottom and mapping template. And we are going to do the same. We choose never pass through and add the mapping template for JSON. Okay. And here I'm going to use another template. So you can see this template, I'm going to construct the request that DynamoDB is expecting. I'm going to use table name, key condition expression, and expression attribute values. So you can see I'm going to query by the ID. So where the IDs come from is coming from the user input in the query string parameters name ID. So I'm going to use this VTL template and click save. Okay, and we're going to test it. So let's try the empty query string, see how API Gateway will respond. So test, you can see 400 error, and the error message is missing the required request parameter because I've already checked the required checkbox. So ID is required. So let's say ID equal to 1 and test it. So API Gateway successfully passed the request to DynamoDB and also successfully passed the DynamoDB response to the customer. But definitely the customer or even the front-end developer is not in the format because they may not understand how DynamoDB works. They may not understand what this response is what does it mean. So we are going to do the transformation in the response. So we click back in here in integration response. We are going to do the same thing in integration request. We are using VTL template to transform the DynamoDB response to the format that we are going to provide to the customer. So here you can see there's a list. What API Gateway do is to read the response code from DynamoDB and search for the list. So we can then I will use this template If DynamoDB is returning 400 error, then I will use the second template. But make the demo simple, I will use the default one, which is every response will use this template. So I'm going to create a template for it. So here you can also see the mapping template. It's just like the integration request, but this time I'm going to transform the response rather than the request. So here, mapping template, I'm going to choose application JSON. You can see here, I'm going to use VTL in this place. So I will use a VTL template here. So you can see in this template, I'm going to do two things. So the first thing is to check in the DynamoDB response if there is anything in the items array. So if no, then I will set context variable, which I've already said the context variable is very useful in API. One of the things is that it can do the response override. You can see I am setting the response status to 404 rather than 200. And I will return this error message to the user that record not found. If not, then I will make a for loop to loop through all the items that DynamoDB have returned, and I will construct an JSON array. And for each JSON array object, I will make the object look like this. ID is the ID that returned from DynamoDB, and for name, I will use the name that returned from DynamoDB. And here I'm also going to add a comma after every object except the last one. So this is a simple JSON format, which the last object won't followed by a comma. So I click save, and we go back, and we do the same test. ID equal to 1, and then you can see the log API gateway is going to transform the body, and after the transform, it will look like this, rather than just returning the DynamoDB response to the user. So you can see the response is easier to read now. And let's try ID equal to 2, then test it. So you can see the status code has been changed by my template that changed to 44, and the error message is what I have written in the template is a message record not found. So I think that's it for creating an API gateway to do read-write on DynamoDB. But if you look into integration requests, you can see actually API gateway can do many things. You can even do a wrapper for your another HTTP request. And if you choose AWS service and you click this button, you can see in the drop-down menu, there are many different API services that you can make use of. For example, if you want to provide an API endpoint to do translation, you can use API gateway to integrate it with Amazon Translate. Yeah, you can see the list that there are many opportunities that you can think of by using API gateway. Okay, so let's go back to the to my slide. So besides the integration part and the validation or request transformation, there are many other features that is very useful in API gateway. First is authentication. API gateway can integrate with a Cognito to do authentication. We can also implement our own authentication logic by writing your customized authorizer using Lambda. The second is catching. We can use API gateway to catch requests. So for some data that is not constantly changing, we can use the catching mechanism from API gateway so that we can use it to avoid overwhelming our downstream services. And number three is usage plan. We can create API key for different customers and attach those API key to usage plan so that we can keep track of the usage for each customer or even limit their usage. It's very useful if you are providing API as a service and you need to track all the customer and charge them. Besides API gateway, AWS also provide different services that help us to handle data flow. And today I'm going to briefly introduce you two of them. First is AWS Appsync. It is a GraphQL API instead of a REST API. GraphQL is very useful for some complex data set. It is originated by Facebook, which you can think of Facebook have many different dimensions of their data. So GraphQL is very useful for those complex data sets. And Appsync support real-time subscription. So when a server side has a data change, it will be reflected in client side without even if the client is offline, they can still access the data or even change the data, and it can do the update after the client is reconnect to the server later. And of course, if we do that, we will face a data conflict issue. Appsync also provide the conflict resolution features using data versioning, and they have their default logic to do a conflict resolution. And definitely, you can also define your own conflict resolution logic. And it works well with AWS Amplify. And so AWS Amplify is a development platform for building web or mobile apps on top of AWS. And if you talk about because AWS Amplify provide many different features, but if you talk about Appsync, what you need to do is that first you have to install the Amplify tools in your local computer. Then what you need to do is to define the GraphQL schema. Then Amplify will do the rest of you. It will create an API for your application to use. It will help you to deploy the Appsync and create the resolver for you. And even further, if you don't have any data store in place yet, it will also create a DynamoDB table for you. So it's if you are developing the client-side application on top of AWS, I definitely recommend you to take a look at AWS Amplify. So the second service I want to introduce is Amazon Kinesis. It is for you to handling real-time data. And so here you can see the input is that we can use API or agent or producer library, which are provided by AWS to push real-time data to Kinesis data stream. And then we have to write a consumer program to process those data. So Kinesis data stream is providing a place for you to streamline the real-time data. But if you don't want to write the consumer program, there's another option, is data file host. Data file host itself is, you can treat it as a consumer. You can place it behind the data stream, and it can help you to extract the data from data stream and store it into S3, Redshift, or Elasticsearch, so that you can do the analysis in those data later on. And we can also use Kinesis data analytics to do an analysis over the data stream. We can use SQL queries or Apache Flink framework to write our program. Then we can place the data analytics behind Kinesis data stream. And it will use our queries or our program to do analytics and output the query result to the Lambda or another Kinesis data stream or data file host. We can store. If we are ingesting a Twitter feed, we can use we can write a SQL command to do the counting on the number of a certain word this kind of work, we can do it in data analytics. So we don't need to spin up a server to inject real-time data and write the program and run it to do the analytics. So Amazon Kinesis will handle all the heavy lifting of handling real-time data for us. So I think I will use this sentence to conclude my presentation. Lambda is not the only thing in serverless, and instead there are many other services provided by AWS. So whenever you start your new serverless project, do more research first. You may find there is already services that you can make use of rather than writing everything in Lambda. So this is my Twitter and LinkedIn. If you want to find me, feel free to ping me in Twitter or LinkedIn, or you can follow me in Medium. So that's all for my presentation. Thank you. Yeah.
That was great. That was clear. Thank you so much. We learn a new thing every day, and that was not deception. That's great.
Welcome.
And I know all our audience is really what they was expecting for. So it was really great. I have a lot of questions, and actually a lot of people in our chat send me a lot of questions to have some time to share with us a little bit what they think. So I will read and put it on the screen. Is it okay with you? Okay, great. Let's see.
Sure.
Okay, the first question here is what do you prefer in API Gateway when you create an API? Is REST API or WebSocket? Which is better? Or
okay, so it is a different usage. So let me share the screen on the page. So whenever you create the API gateway, there are many different options. So the first that is many people use REST API. REST API is you can definitely use it for anything. But if you use a WebSocket API, is for real-time use case. So what WebSocket API do is that I don't have a diagram, but I will try my best to explain it. WebSocket API, if you don't know WebSocket, this is like a long polling HTTP. So whenever a client is connecting to the server, it will create a connection which will not end. So whenever there's a connect action, WebSocket API will fire an event to you. You can use Lambda to handle it. It will provide you the connection ID that is specifically delegated to that specific connection. And you can do everything with this connection ID. You can save it into Lambda and map it to your, maybe you can map it to your own service username. And so then whenever you have some, let's say, notification or update to that particular user, you can grab the user ID and then send the data you want to send to the user. You send to the API Gateway. API Gateway will provide you another special endpoint so that you can send the data to it. And you send the data to WebSocket API with the connection ID. Then API Gateway will help you to send the data or push the data to the client. So the client can instantly see the data. You don't need to tell the client to refresh and refetch the data. It is for real-time usage. And for HTTP API, is just I think it's just introduced. I think it's last year. You can see HTTP API. You can only do not many things. It only provides you to do HTTP or Lambda. You cannot do whatever I did in the demo. And it lacks the many features. But why Amazon provide this service? Because it observed that many people use a REST API, which is quite expensive, I can say, but do a simple thing, just like the Hello World sample. It just pass the request to Lambda function, which is an overkill to REST API, and is really expensive. So Amazon provide a downscale service, which is called HTTP API, which I think is really cheap compared to REST API. So that if we are only using it to pass request to Lambda, then we definitely need to use HTTP API.
Okay, thanks, Richard.
Yeah.
So the next questions about security. You tell us.
Yeah.
We're working a lot in AWS security and securing accounts. So this is a little bit of security here. And the question is, in terms of security architectures, can we use this approach in production environments? And this goes along with the thing of avoiding using Lambda to go direct to DynamoDB. So in terms of security architecture, what do you think about that? Is the right thing avoiding that? Maybe a little bit of cost effective. I don't know about being cost effective in this architecture. Avoiding Lambda maybe avoid these compute costs, but you tell us.
In terms of cost, I will not say is a really big difference, because Lambda is really cheap. You can